In this short video, we are going to do a brief introduction to slope. Our objectives in this video are to define and compute slope and to explain the relationship between slope and something you already know about, unit rates. Before we get into all of the details about slope, let's go back and look at unit rate and see how we can graph data to get a unit rate. Keep in mind that a unit rate is any rate where the denominator is 1. In this first example, we have a set of data where our first column represents the weight and the second column represents the number of boxes. Something that we must always keep in mind is that whatever is in the first column will always be on our horizontal or our x-axis. So weight will be graphed here on the horizontal axis, and the number of boxes will be graphed on our vertical axis. Let's now plot each point. Our first point, the weight is 6 pounds, the number of boxes is 2. So we'll go to 1, 2, 3, 4, 5, 6 on the x-axis, up 2, and there's our first point. Then we graph 12, 4. 1, 2, 3, 4, 5, 6, 12, 4 would be this point. 15, 5 is this point. And 18, 6 would be this point. Now, one of the things that we want to do is we want to draw a straight line starting at our origin and going through all of our points. When we draw the line, this is what our graph would look like. So we've accomplished the first part of our assignment. We have graphed the data. Now we need to find the unit rate. Our unit rate would be, and I'll just abbreviate this with a UR. We always take the second column, divide it by the first. So our unit rate is 2 boxes divided by 6 pounds. And we will reduce that fraction to 1/3 of a box per pound. That would be our unit rate. So every pound would need to be in 1/3 of a box. Now, if you think back to when we talked about unit rates before, we talked about how sometimes we would get crazy numbers like that. And that, we look at these numbers and it makes us feel better to say, oh, well, can't we just say 3 pounds per box? Yes and no. If we want to keep strict to the rules about functions and data for things that we will be doing later on in our math careers, our math learning, we want to always get in the habit of making that second column of our data table our numerator whenever we're doing any kind of ratio, fraction, etc. So we're going to stick with 1/3 of a box per pound. Now we're going to look at our second example. First column we have the number of hens, so that is our horizontal axis, our x-axis, and our second column is the number of eggs, so that's our vertical or our y-axis. And let's graph those points. Okay, the first point we have is 3 hens and 6 eggs. So we go over 1, 2, 3, up 1, 2, 3, 4, 5, 6. Our next one is 4, 8. The next point is 5, 10. And our last point is 6, 12. And all that remains is to draw our line. Draw our line from our origin through our points. And we get something that looks a little like that. So there's the graph of our data. Now let's find the unit rate. Just like we did before, we're going to take 6 divided by 3, and we will get 2 eggs per hen is our rate. Alright, so that's just a quick review of unit rates, and we've done some graphs of those. Your worksheet that you are taking notes on has 2 more examples, but we're only going to do, in the interest of time, these 2 examples. However, as part of your homework, I still want you to do examples 3 and 4 before you move on to the next aspect. Okay, so now let's look at this whole terminology of slope. And I think we all have an idea about what slope is because we think of the slope of a mountain. It can tell us how steep an angle is, how steep the slant of an angle is if we think about it in those terms. But slope has a very specific definition from an algebra standpoint. And even that definition leads us to the ideas of slope, where we measure how steep the side of a mountain is, etc. It all comes from the algebraic definition of slope. So let's talk about what that definition is. The official algebraic definition for slope is the ratio of the vertical change in a line to the horizontal change in a line. Slope is really a ratio, and we know that ratios are a comparison of 2 quantities, and when we're talking about a line and slope in particular, the 2 quantities we're comparing is the vertical change to the horizontal change. You will often see slope defined in more everyday terms as rise over run. From a mathematical standpoint, a simpler definition many times is change in y over the change in x. Those little triangles are actually the Greek letter deltas, and they stand for change. But that is the basic idea for how to find slope. What we're going to do now is we're going to go back to our first 2 examples where we graphed and found the unit rate, and we're going to find the slope of the lines that we created in those graphs to see how slope relates to all of that. Okay, so here's all of the work we did for our first example. You see the graph of our line, and what we're going to do is we're going to find the slope of this line. And we can pick any 2 points on this line and find the slope. I'm going to pick this point and this point. And the way that I'm going to do this is I'm going to draw a little triangle that connects these 2 dots. I could draw the sides of my triangle in red. and we can see we have this triangle. And we're going to measure the sides of our triangle, and because it's this nice, neat little 90-degree angle, it'll be easy to measure the sides of the triangle. Well, the vertical side of this triangle, the up and down side, this is 2 units tall. And the horizontal side, the one going left to right, that side is, if we count our boxes, is 6 units tall. Now, if we go back to our definition of slope, and I'm running out of room and places to work, but if we go, slope is defined as rise over run, which is the same as the vertical over the horizontal. Well, the vertical side of our triangle is 2. The horizontal side of our triangle is 6. And we can already see that this ratio, 2/6, was the same as our unit rate. So we know, and even as we reduce this, that this is going to reduce to, again, I'm running out of room, 1/3. So when we graph a unit rate and we measure the slope of the line, we'll find that the slope and the unit rate are the same thing. If we take the time to do that for our second example, we would find that slope and the unit rate would be the same for example 2. What I would like for you to do now is for what's called examples 5, 6, and 7 on your sheet. So I would like for you to go find the slope of each one of those, because that would give you the unit rate. We'll do the first one together. On your sheet, this is example 5. Our instructions for this sheet tell us to find the slope for each line. All right, here's our graph. We just have to pick any 2 points on this line. One of the things we want to make sure that we do is we want to make sure that we pick points where our line is going right through a nice, neat little intersection. And there's one of those points right here. So I'm going to select this point. Okay. And as I look up and down my line, I see another point like that. Where's a good point? Right here is a good one. So we'll pick this point. And now what we want to do is draw our triangle. Need to draw a thicker line here. That's not showing up very well. Let's try that again. Okay, now we can measure just by counting our blocks and find out what the slope is for this thing. Let's do our horizontal distance. On our horizontal graph, each one of our blocks represents 1, so we've got 1, 2, 3, 4, 5. Our horizontal distance is 5. On our vertical axis, we see our scale is much different. each block represents a unit of 5. So we're going from 20 here to 75. That should come out to be 55, but let's count it if we count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So now to find the slope, we're going to do rise over run Our vertical distance is 55. Our horizontal difference is 5. So our slope reduces to 11. That's the slope. The second half of the problem tells us to find out what the unit rate would represent. This is where it's important to be able to not just come up with a numeric answer, but to be able to interpret what that numeric answer is. We know that our slope is 11, so now we're changing to talk about the unit rate. And here's how we take our slope and turn it into a unit rate. We know numerically it'll be the same as 11. And to determine what the units are on our unit rate, we would look at the labels on our axis. The slope is rise over run. So we take our vertical unit first, kittens, put that on top. Run is our horizontal, so we take our horizontal unit, put it on the bottom. So our slope of 11 represents 11 kittens per litter. You'll do the same thing for example 6 and example 7. I want you to try those on your own, find the slope, and determine what the unit rate represents. This is example 6. Find the slope, push pause first, then find the slope, write down what the unit rate would represent, then hit play to see if you got the answer correct. Okay, I'm going to pick a couple of points. I'm going to pick, and you can pick any 2 points you want, but I'm going to pick this point and this point. And let's draw the sides of our triangle. And measure them on our horizontal axis. Each square represents 1. So this is the length of my horizontal line is 1, 2, 3, 4, 5, 6. So length of 6. And my vertical, each line represents 20. So that's 20, 40, 60, 80. So my slope, which is rise over run, is 80 over 6. That reduces to 40 over 3, and we're just going to leave that as an improper fraction. Always leave slope as an improper fraction. There may come a time when you will change it to a mixed number or something else, maybe decimal form, depends upon the context, but for right now, when we're beginning slope, leave it as a improper fraction. Our next step is to now talk about what that unit rate would represent. Remember, we take our vertical unit over our horizontal unit, so our unit rate is, and this is where I'm going to change this to an improper fraction. 40 over 3, as a mixed number, 40 over 3 is 13 1/3 miles per gallon, and that's what the unit rate represents. Final example, example 7. You find the slope. You tell me what the unit rate represents. So go ahead and hit pause and then come back and see if you got the right answer. Okay, when I go to do this, I'm going to pick this point because it's going right through that intersection of those, and I'm going to pick this point. I'm going to draw a nice thick line here so I can see my triangle clearly, and both the horizontal and the vertical axis, each unit is 3, so this is 3, this is 3. My slope is rise over run 3 over 3, which reduces to 1. My unit rate represents 1. My vertical unit is desk. My horizontal unit is student. So my unit rate represents 1 desk per student, which kind of makes sense. Alright, so that's all we have about unit rates and slope. I apologize that this video was a little bit longer than I anticipated, but the key thing to remember is that slope is defined as rise over run, or the change in y over the change of x, and slope and unit rate will always be the same number. That they are two different ways of referring and computing the same ratio.